Howdy everybody. In this video, we are going to do some Salesforce analysis. Okay, a lot of companies maintain huge Salesforce databases or data sets, whatever you want to call it. It can be pretty extensive. It can become somewhat small. Really depends on the size of the enterprise, right? But this data is very valuable. I think a lot of people just do very primitive analyses on these types of things, or maybe none whatsoever. I know companies that have Salesforce data and they don't even analyze it really. It just kind of sits there. And it's useful for contacting customers, seeing the last time they made a purchase and interacting with the customer, right? But they don't necessarily analyze it. I think it's very interesting though to take this perspective and do a deep dive on some topics here to see what the data is telling us and see if we can do one of two things: either make more money with our analysis or somehow save money with this analysis, right? Usually you're trying to do one of two things in the data science world: make more or save more. I think if you can save more, it's basically eliminating inefficiencies in the business, and that's pretty easy to do in a lot of cases. If you make more, you're probably going to have to work harder. You're probably going to have to install some new infrastructure or architecture or who knows what. But you can make more money too. But when you make more, you have to pay taxes on the extra income, right? So I think saving money should be the focus over making more. But certainly those are two focuses for most businesses, right? So we're going to look at customer segmentation and these examples below. We're going to look at some predictive analytics, sales and marketing effectiveness, customer experience, overall operational efficiency, financial performance and forecasting, and so on and so forth. Okay, so we have to prepare the data, do any cleaning, any kind of EDA exploratory data analysis, that's plotting and charting of the data. So if you plot your data and you get a visual and you have this chart, a picture could be worth 1,000 words, right? You could illustrate something in a chart or graph and show it to a client or stakeholder, and they can say, yes, I understand what this is, quickly and easily. If you have to describe that to them, that could take 1,000 words to communicate that same message, right? So we have model building. We'll be building several models and testing it. We'll be generating some actual insights, and by leveraging all these techniques, we should be able to tease out some very interesting nuances in this data. Okay, so here's the data. I don't actually have Salesforce data. That would be confidential and highly personal. I'm just going to create some realistic data here to show you the mechanics of how to do this type of analysis. Again, you would plug in your own data for this. I don't have that, so I'm just making mine up. So in the first case, this is what the data looks like, by the way. We have the age of the customer, company size, industry, and a few other features relevant to our Salesforce data here. So the first thing we're going to do is label and code this data. So machine learning models do very well for when working with numerics. They don't work with any kind of text or objects. Text could be large, medium, and small. That's important to describe the size of the company. But if you put that into an ML model, it's going to generate an error, right? It doesn't know what large, medium, and small is. But you can label and code large, medium, and small and have a 1, 2, and 3. And then the computer will say, okay, I know what that is. And then I can train the model and test the model and see what the predictive capabilities of that is. So we're sending the target variable as average purchase value, right? And these are the independent variables. So these are the X values right here, right? Looking at all these features, I'm going to see which ones are going to have the largest statistical impact on the target variable, which is average purchase value. So Control Enter to run. Okay. And we'll see what the ML model spits out. Okay. Pretty horrible performance, negative 0.15. This R-squared, you want to see at least over 0.70, and you certainly want to be positive. Anything north of 0.90, 0.95, the model's learning and it's making highly accurate predictions. This model is totally inappropriate here. It actually has a negative R-squared. That sounds weird. That can happen. It's not a mistake, but it just means that the model is not learning well at all. So this model is basically useless for us, but that's okay. We have another idea that we're going to test. We have our categorical features and our numerical features. Again, anything that's categorical has to be label and coded. That's what the LE is doing here. And by the way, I'm going to give you all this code. When I post a video, I'm going to save this file as an HTML file. You can download it and run this in your Jupyter notebook environment, just like I'm doing right now. And you'll get exactly the same results. And again, you would use you would substitute your specific Salesforce data for my hypothetical data that I generated, and you're good to go. It's just that easy. So here we're looking at feature importance exercise. These features have the highest statistical impact or influence on the target variable. Let me go up and see what that was again. We said the target was and is average purchase value. Okay, so that's what we're trying to measure here. Average purchase value, and these features right here, last purchase days ago. So the more recent the customer purchased from you, that is going to determine, are they likely to buy again? Annual revenue of the company. Probably larger companies spend more, right? Number of purchases in the past. So more purchases from these clients is going to generate like a higher purchase value, right? They just tend to buy with you and give you their business over and over repeatedly, right? So that's what we're seeing here. That's good. That's great. That's very useful. Let me look at this. Oh, this code runs slowly. I ran this before I started the video because some of these models do take quite a while to run. So I'm not going to rerun this. This is going to take way too long. Again, I'm going to share all the code with you so you can copy and paste it and run it in your environment. I'm just going to skip to the bottom and see what the result is. So we're adding some parameters, tuning these hyperparameters, and trying to get this model to perform better than the last one, right? So we're doing a little feature engineering and playing around with the parameters of the model to try to get a higher R score. When I ran this, it was just slightly higher. It's still meaningless and it's still a bad model. It's not doing anything. It's not learning. It's not making accurate predictions for us. So we're just going to switch gears and just try something completely different. Okay, we can run a classification experiment. Again, in the world of machine learning, you have regression and classification, classifiers, or for predicting target variable is high value client. These are the independent features, right? Independent variables. So these will be the X. This is going to be the Y, the target variable. And we're going to run the model. This time we have, I believe, we had to do the label encoding again, okay, just to get everything that's not numeric into some type of numeric format. And then, okay, random forest classifier. Okay, that's what I thought. So we did random forest regressor before. That didn't work. Random forest classifier is running for us. And it runs pretty quickly. And it says predicted probability of being a high value client is about 43%. Okay, so when you feed in these features right here, you're trying to predict, is this a high value client? A little bit more than 40% of the time, yes, it is a high value client. So that's somebody that you want to take care of. Take them out for dinner once in a while. Who knows? Take them to a Knicks game or something like that. Like, you want to take care of these guys. These are high value clients, and 43% chance of determining that from that classification model we just ran. Now, let's see. This is okay. Log regressor, support vector machines. Okay, so here's a few more models. We're going to try a bunch of different models now to see which one potentially could be working for us. And in this instance, again, I'm going to copy and paste all this code so you don't have to worry about all the details now. You can run this in your environment and you're going to be good to go. So the first model right here is giving me F1 score 0.39. You want this to be close to 1. You want all these to be kind of close to 1. This is 0.55. Precision, regression. These numbers are actually pretty low. This 0.71 is a little bit high, but really you want to see that closer to 1, like 0.9, 0.85, something like that. So all these models right here are really not helping to make any kind of prediction. And that's okay. We just run these experiments to see what the outcome is. You would never know what the outcome is until you run the experiment, but you run it, see if the model is learning, see if it's able to make predictions. If it is, then you go with it. If it's not, then you just ignore that, right? And pick a different model. So moving on here. This also takes a long time to run. Now we're doing a similar analysis that we just did in the last example, but you saw all of those accuracies, precisions, F1 scores are pretty low. Really, we want to get close to 1%, right? So I'm doing everything the same as before, but I'm going to add in cross-training and validation to this model. Okay, that's what this step is doing. And then let me see if we go down a little bit. Okay, we're doing some splits and samples of the smallest class. Okay, so again, updating the features and the parameters. So we're training some some hyperparameters as well. So we're adding in more features, training and tuning the hyperparameters. And then we are going to go ahead and rerun the model. Don't worry about all this code detail. There's a lot here, but I will save this file, share it with you. You can copy paste it and run it and see exactly how it works. So now, after setting all the parameters and tuning these parameters, now we're getting accuracy, precision, recall, and F1 score all of 1. So this is an excellent model right now. So the original model out of the box really didn't perform that well. This one has been trained and it's able to make accurate classification predictions, and we're good to go with this model. This is working excellent at this point. So yeah, they're all 100%. This is excellent. Here I have some notes about regression, classifications, and kind of label encoded data or label data, large, medium, small, and regression is for any kind of numeric data or continuous data, right? So let's move on and try a clustering experiment at this point. I'm going to go ahead and hit Control-Enter to refresh. Okay, and now we see the clustering of basically company size and industry. So this is very interesting now. We're looking at industry, company size. On the y-axis, we have the number of purchases, and on the x-axis, we have annual revenue. So anything in this southwest quadrant, there's these clients or these types of firms and the size of firm are not spending a whole lot of money, right? In the northeast, you have a lot more spend and more frequent purchases too. So we're looking at large healthcare, small tech, small manufacturing, medium manufacturing, healthcare. So healthcare, tech, and manufacturing, these are the clients that we should be focusing on. They have more spend with us, and just overall, yeah, you want to take care of these. These are like the high net worth clients for us. Okay, so that's what the clustering experiment is for. It's to take everything that's in a similar cluster and move that into a group, right? And then plot the results so you can visually see that. You can print the results of the clustering too, and plot it. I like to plot it at least. You can print it as well if it suits you. So we see everything over here in the northeast quadrant. These are the high value customers that you want to be taking care of. Large healthcare, small tech, small manufacturing, and medium manufacturing. Okay, moving down, we have hierarchical clustering. Now I ran this. I'll refresh it and show you what it looks like. This could be useful. It's kind of jam-packed with information. It's almost information overload. So I don't know how useful this is. And in this scenario, you'd have to zoom in and see all the details here to see if this is useful for you. I think it's a little bit overwhelming. I didn't know that until I ran the experiment. I ran it, and I would say this probably isn't too helpful, although we can see it is doing the clustering. We have an orange cluster, a green, and a red on the right, and you have all of the same features that we saw before. We have the, what is this specifically? Yeah, company size and industry broken down into different clusters using hierarchical clustering. So it's working. Is that super useful? I would say not. It's just too busy. It's just too much going on. But the first clustering experiment worked pretty well. And there's a couple more I'm going to show you in just a minute. The first one is KMeans clustering. This is DBSCAN. I have another video just on comparing different clustering methodologies and seeing how each one works out. Some perform excellent. Some don't perform quite as well. You really have to run a bunch of them. I think there's about 7 or 8. It might be top 10 actually. You can run all of them pretty quickly and easily. I have a video that shows how to do that. And only then will you know how the clustering algorithms are performing, right? So this one seems to kind of be performing pretty well. Again, like the K-means, we'd look at the annual revenue on the x-axis, number of purchases on the right. So we'd look in the upper northeast quadrant, and I can see AR and CS. What is that again? Let me go back here. Oh, annual revenue and company size. So you can see the company size and the industry, right? So, number of purchases. Okay, so this has 4 features. So annual revenue, number of purchases, company size, and industry. And you can see in the Northwest, small tech, large healthcare, small manufacturing. I'm looking at small manufacturing again, medium manufacturing. So these are the customers that we really need to take care of. These are the high net worth guys, and they're giving us most of the business. They have most frequent purchase patterns and the largest spends. So let's go down here. I think there's one more clustering exercise. Yep, there is Control Enter to refresh. Let's see what this looks like. Okay, so this is a different type of clustering. Agglomerative. We looked at KMeans and DBSCAN. Agglomerative clustering is another technique that we can employ here. So here we're seeing same thing, revenue and purchases, large healthcare, small tech, small manufacturing, medium manufacturing. So kind of the same story as the other clustering. Sometimes the clustering experiments turn out quite a bit different. In this case, all three are coming back like pretty similar here, okay? Was there one more clustering experiment? Let me see. Oh, there is, yeah. GMM. Okay, so let me hit Enter, Control Enter to run this, and we'll see what the outcome is. Again, clusters 0, 1, and 2. It's 0 base, so it always starts with 0. You have 3 clusters here, and you're looking at the annual revenue and number of purchases, okay? So this is all fine. I think it's fine. I think it's interesting and useful. It's doing what it's supposed to do. We know which customers we have to focus on. All those guys in the northeast quadrant, okay? And then I think it's kind of it here. So anything that I didn't have, you can easily add into your analysis. You probably have more features than I have. I just made up this data, right? But your data set's probably much richer than mine with a lot more details. So go ahead and add that in, run the code, make the obvious adjustments like the data frame, name, convention, and any feature names will have to be updated. But for the most part, it's just a copy paste exercise. Run this on your data, see what the outcome is going to be. I think it's going to be very, very interesting and very informative. Any more last things here? Predictive modeling, we talked about that. This is a couple other types of analysis. I have another video that I talk about this. I didn't do it here because it's covered in another video about customer lifetime value, churn analysis. These are things that you might want to do. I didn't do it in this data set. Again, I have another video that addresses that specifically. And then any kind of cost to serve analysis. How much does it cost to take care of these customers? That's one consideration. Efficiency improvements, that's something that you might want to consider. Upselling and cross-selling, of course, right? If we have customers that like the products, cross-sell. It's very easy to take care of a customer and keep the customer happy. It's not necessarily easy to go out and find a brand new customer, right? Customer retention strategies. So that's another attribute that we can take a look at. And then market basket analysis, identify any kind of potential threats or challenges or competitors, right? Understanding the competitiveness of the market that you're operating in is always important too. Okay, so I think that's it. Hopefully you guys learned a thing or two with this exercise. Thanks for your time today. Have a great day. Goodbye.